we'll discuss about maximum power transfer and superpositions. That was the remain part of the for chapter 4.3 for the ENGR 210 circuit analysis class. So if we wanted to the maximum power transfer to the resistivity rod, rod resistor R sub L, rod resistor and then Thevenin resistor should be the same. Okay, should be the same. From maybe if we know the Thevenin equivalent the circuit. Okay, and also after we find R sub L from Thevenin resistor, we can also the calculated maximum power P sub max, that was the Thevenin voltage square over 4 times the rod resistor. Okay, so it means if we wanted to the condition for maximum power transfer to a resistive rod and maximum power transfer to the resistor rod, we needed to find the Thevenin equivalent circuit, which include the R sub TH and P sub TH. So from the sample questions, we can try to find this one. I'm going to remove A and B. Just a second. Oops. Oops. There. There we go. Yeah. All right. So the question is, we have to find R sub L, the question A, and then for maximum power being transferred to the R sub L. That is the circuit, okay? So that was the blue rectangular part. We have to the transfer to 1 V sub TH and R sub TH, okay? And A and B, we can find the R sub L. That should be R sub TH. And then we can find P sub max, 4 sub R sub L over sub TH squared, okay? Definitely, that is the unit watt. That unit is ohm. All right, so I'm going to quickly go over. So the first order direct method, we can, short circuit right there. This is voltage sources. We can make a short circuit. So it means the 30 ohm, 150 ohm, that was for in the pedal. So we can calculate it 25 ohm, okay? This is the Thevenin resistor. And then go back to the circuit. The before connection, the R sub L, the open circuit, so the V sub AV is the Thevenin voltage. So from this circuit, we can do voltage divider rule, 150 over supply voltage. That was for Thevenin voltage. So write this one. Okay, this is voltage. So we found to the Thevenin voltage by using voltage divider rule and also direct method. We can find the Thevenin resistance. So faster. It's good. So now, so after we connect to the road resistor R sub L in the open circuit A and B, and then we can find the R sub L is equal to R sub TH, mean P4 R sub L is maximized. The answer for 25 ohm. Okay, and then the P sub max, we have already know the formula. We know the R sub L, 25 ohm. V sub TH is like 300 voltage. Finally, we can find 900 watt. That was maximum power for the R sub L. Okay. All right. The last question. The last question is when R sub L is adjusted for maximum power transfer, what percentage for power delivered by the 360 voltage sources reach the R sub L? So in here, the first number we have to find the maximum power, but we have already know the maximum power in the Thevenin equivalent circuit for R sub L, 900 watts, 900 watts, okay? And also we have to find the power for supply voltage, okay? The passive sign conventions, we needed to, that was supply means minus VI. V is 360 volt. I sub S, that was 150 voltage, and so right there, because we have already calculated from Thevenin, circuit, voltage divider rule, 150 voltage. So this is why. So 360 volt minus 150 volt. So divided, I'm sorry, 30 ohm. Finally, that was the 7N. So 7N plug in the I, and finally, that was supply. Minus mean is not minus, okay? Physical meaning. That was supply, okay? So 2.5 the kilowatts. So the percentage, the ratio of the source power to the rod power, so 900 the power for the R sub L maximum power, supply voltage 2520, multiply 100, it's like the 35.71 percentage, okay? All right. So the next topic is superposition. What is superposition? So superposition theorem, the circuit with multiple power sources, okay? So sometimes independent current sources, sometimes independent voltage sources. can be analyzed by evaluating only one power sources at a time. So in other words, superposition, circuits theorem that simplify analysis of circuit with multiple sources by breaking them down into simple circuit. So for example, from this circuit, they have the two independent sources. So first of all, we learned before, that was the open circuit, and then plus minus, that was the short circuit. Okay. So at the time, for example, the keep saying the voltage source is 120 volt, just the one, just that we're gonna to independent current sources, the open circuit, and also the independent current sources in the keep staying there, but the independent voltage sources, that was for the open source voltage source. Okay. So the question is, use superposition principle to find the branch currents in the circuit. It's like this one. Now, step by step. Step one, we wanted to keep the staying the independent voltage sources, but the independent current sources, we're going to the open sources. Okay. So in here, we know that the node voltage across the 3 ohm to register. The one denoting that was the V sub 1 here. Okay, this is the V sub 1. So the V sub 1 minus 120 divided 6 ohm. Okay, there was a leaving in the plus, and V sub 1 over 3, that is also leaving, plus V sub 1 maybe over the 2 plus 4. Why? Because that was the open circuit. Okay, that was the nothing. Okay. So that was the in series connection between 2 resistors, 2 and 4 ohm. So in here, one variable, one equations, finally we can find V sub 1, the 30 voltage. So in here, we can find the I sub 1 prime, I sub 2 prime, I sub 3 prime, I sub 4 prime. I sub 3 prime and I sub 4 prime, it's the same. You might be able to ask me, why do you have to find I sub 1 and what is I sub 1 prime? Because the question is, we have to find I sub 1, I sub 2, I sub 3, I sub 4. So maybe it depends on removing or keep staying independent sources. We have to combine I sub 1 for the 2 Ks, okay, to find the maybe to each branch the circuit. Okay, so I sub the 1 prime 120 volt minus the 30 volt. 30 volt is V sub 1 but divided 6 ohm. Okay, I sub 2. The arrow from the V sub 1 node is like the high and to low. That was this to ground. So that was ground high to the ground, high to the low. So 30 minus 0 divided 3 ohm. So that was 10 amp. And I sub 3 and 4 is same thing. So 30 over V sub 1 divided the total register is like 5 amp. Now, now, in here, the voltage sources is like the short circuit right there. And the independent current sources is going down. Okay. This is 12 amp. All right. Now, so we'll try to make it in this circuit, the 2 node, actually 2 essential node, V sub 3 and V sub 4. So in here, the node analysis is like V sub 3 over 3, V sub 3 over 6, V sub 3 minus V sub 4 divided 2 is equal to 0. And also V sub 4 minus V sub 3 divided 2, V sub 4 over 4, and the 12 and the leaving from the node, so we can also go into 0. So they have the V sub 3, V sub 4, 2 variable, 2 equations, and then we can calculate. I'm going to skip the calculation. So the I sub 1, the 2 prime 4, which is to keep staying the independent current sources, and I sub 2 is also 2 prime, V sub 3 divided 3, and I sub 3, 2 prime, that was V sub 3 minus V sub 4, that divided the register Ohm's law, 6 amp minus the 6 amp, okay? So after that, we find the 2 cases, keep staying voltage and, deactivating independent current sources, independent current sources activated, voltage sources deactivated. So finally, I sub 1, 2, 3, 4 for each, the 2 different case, I sub 1 prime plus I 1 sub prime 2, I sub 2 prime plus I sub prime 2, something like this. So all the value summation, finally we can get the currents, what we wanted to do for branch circuit from the circuit.